All right, so this is class number 5, where we will be talking about congruent triangles. So first up, we will be classifying triangles, and usually we can classify it as 3 different types. We can classify it as scalene, isosceles, and equilateral. So scalene means that there are no congruent sides, meaning all sides are different lengths, and the angles are all different measures. For isosceles, it means that there are 2 congruent sides, and 2 of the angles and 2 of the sides are equal. And then equilateral, as its name suggests, it means all congruent sides and all congruent angles. So the 60-60-60 equilateral triangle would be an equilateral triangle. Next up, classifying triangles by angles. So there's the right, acute, obtuse, and equilateral. So for the right angle triangle, it would be one right angle and then 2 other different angle measures. Acute would be 3 acute angles, all which means angles less than 90. And then afterwards, lastly, we would have the obtuse triangle, which is a triangle that has 1 obtuse angle. And then lastly, we would have the equilateral triangle, which has 3 congruent angles. All right. Second. All right. So next up, for angles, we have a few different kinds of angles. So first up, we have the interior angles, which are the angles formed inside the triangle, which are these green angles you see here, represented by alpha, beta, and y. Next up, we have exterior angles, which are outside angles formed when lines are extended. So which are all of these different red angles. Of course, there's a lot more different exterior angles, but these are just a few of the examples. Next up, we have some theorems. So a few of the theorems we have here are the triangle sum theorem, which means that the sum of the angle measures of the interior angles of a triangle is 180 degrees. So let me do some annotating. One moment. All right. So basically what it means is that in this triangle you see down below, the measure of angle A plus measure of angle, wrote that wrong, measure should be the other way, measure of angle A plus measure of angle B plus measure of angle C equals 180 degrees. This holds true for any triangle. Next up, we have the exterior angles theorem, which means that the measure of an exterior angle triangle, the measure of an exterior angle of a triangle is equal to the sum of the measure of the 2 non-adjacent interior angles. So, one sec, let me admit person. All right. So next up, what the exterior angles theorem basically says is that if we have a line here, right, not the best of lines, but let's just say that is a straight line, and we'll call this angle D, right? Well, first of all, you can say that measure of angle C and measure of angle C plus measure of angle D forms a linear pair. And then, for example, we say that this degree is equal to 54 degrees, this one equal to 67, and this one equal to 59 degrees. So in this case, the measure of angle D would equal 126 degrees. So basically, the measure of angle D would be the measure of these 2 angles, measure A of angle A and angle B, because when you think about it, right, because angle A plus angle B plus angle C equals 180 degrees, right? And then angle C plus angle D equals 180 degrees, right? So in this case, if these two equations, if we were to set them equal, right, we would get angle A plus angle B plus angle C is equal to angle C plus angle D, right? So now we have this balanced second. So now we have this balanced equation, and then we can cross out the angle C's, and then you can see that angle D is equal to measure of angle A plus measure of angle B, right? Next up, we have the corollary to the triangle sum theorem, which says the acute angles of a right triangle are complementary, which complementary, as we talked about, means equal to 90 degrees. So for example, let me draw a triangle. So for example, we have this right angle triangle right here, this angle. So these two angles, right, the acute angles right here, A and B, these would be complementary, meaning that measure of angle A plus measure of angle B equals 90 degrees. Does anyone have any questions on any of these theorems? All right, I do not see any questions, so I'll keep on going. Of course, if you have any questions while we are, that come up in the midst of it, just type them in the chat box and then I will answer them. All right, next up, we have a proof. So given that triangle ABC is a right triangle, prove that angle A and angle B are complementary angles, complementary being adding up to 90 degrees. So let's take 10 minutes for you guys to work on this proof. And then once you're done, you can just type your answer in the chat box and I'll look it over. And once we finish all of that, I'll go through this problem. And of course, if you have any questions while working through this problem, you can either unmute or you can just type your question in the chat box and I'll answer it for you. I'm just letting you guys know that like every minute or so, I'm just gonna every like 2 minutes or so, I'm gonna just write one of the steps on the screen. So in case you're stuck on one step and you like don't know how to get past it, hopefully you'll be able to see that, like get past that one step you're stuck on and be able to finish the problem. We'll just take another 3 minutes or so to work on this problem. So just if you're stuck, ask me. Ask me, and if you're finished, just put your answer in the chat box. And then at the end of the 3 minutes, if you haven't finished, that's completely fine. You can just type in whatever you have gone through so far. All right, we'll just take another minute or so to wrap up this question. All right. So guys, please just put whatever, please put your answers in the chat box. It's completely fine if you didn't finish it all. Just put whatever you have so far in the chat box, and once you have, I will go over the answer. All right, so I'll go over the answer now. So first up, in any geometric proof, right, we want to state the givens, and the given is triangle ABC is a right triangle. So first, we want to, of course, write that triangle ABC is a right triangle, which is given. That would be our reasoning. Next up, we have measure of angle C equals 90 degrees. And then for that, we can just say diagram given, because in the diagram, we can see that angle C is the 90-degree angle. Next up, we would have to say angles A plus angles B 180. So we ran out of room there. Angle A plus angle B plus angle C equals 180 degrees, which would be what we just talked about, the triangle sum theorem, which states that angles of a triangle add up to 180 degrees. Next up, from there, right, we would go into angle A plus angle B plus 90 degrees. Sorry, wait, this should just be angle C. Sorry about that. Equals 180 degrees. And this would be through substitution, right? Because we have already determined here that angle C is equal to 90 degrees. So henceforth, we can freely substitute in 90 degrees for angle C, or angle C for 90 degrees. So now that we are at this step, right, we can further simplify this equation. So that there we have, what is it called? You can do this step, angle A plus angle B plus, sorry. Oh, why is this not erasing? 1 second. There we go. Angle A plus angle B equals 90 degrees, which is the subtraction property of equality. I just shorthanded that, which basically says that, when you see this, you can subtract 90 from both sides. After this, right, we can say that angle A and angle B are complementary. And the reason behind this would be the definition of complementary angles, which the definition of complementary angles states that with two angles add up to 90 degrees, then they are complementary. So this is how you would do a geometric proof. On one side, you would have all of your, why is it not letting me select the color? So on one side, right, usually on your right side, you would have all of your steps, your step-by-step process to solving it. And then on the other side, right, you would have all of your definitions, proofs, basically your reasoning for why you can do this, and why this is acceptable, right? Geometry is very tedious. Whenever you do proofs, you have to list all of these, step-by-step processes. You can never skip a step in these geometric proofs, because it'd be kind of like building a car, but you forget to put on a nail, or forget to put in a screw, because you skipped a step in the instructions. So even though some of these parts seem very unnecessary, I guess, they are all required, to show that you understand the step-by-step processes in doing a geometric proof. Does anyone have any questions on this one? All right, I do not see any questions, so I will keep on going. Next up, we will be talking about corresponding parts. So determine the corresponding angles. So in this case, angle A corresponds to angle D, angle B corresponds to angle E, and angle C corresponds to the angle F. And then determining the corresponding side, angle A, side AB would correspond to angle DE, angle BC would side BC, sorry, would correspond to angle EF, and lastly, side CA would correspond to side FD. And then you can just see which are the corresponding parts, because when you look at these different drawings, right, you can see that this one has one line and this one also has one line. And also by looking at the shape of the triangle, you can see that these two, like which angles match up. And just because they say they are corresponding doesn't mean they are equal to one another. All right, and then in this, similarly, we can say angle ABC is congruent to angle DEF, and angle triangle BCA is congruent to EFD, and a triangle CAB is congruent to triangle FDE. In this case, why I included this is just to show that order matters very much. You'll get into this later in pre-calculus when you talk about vectors and direction. But basically, just know that kind of when you say triangle ABC, right, you're going from A to B to C. And then for angle DEF, right, you're still going angle D to E to F, like so. But for example, you can't say triangle ABC is congruent to EFD. You cannot say that, because so triangle ABC stays the same, right? You just go from here, here, here. But for triangle EFD, you'd be starting on the top, going to the left, and then going up. So you kind of see how the order is different. And although it, they're the same, what comes out is, essentially the same triangle. It has all the same stuff. The side lengths don't change, the angle measures don't change, but it's just something that you have to pay attention and keep in mind when you're talking about corresponding sides, corresponding angles, to make sure that the order is the same. Does anyone have any questions on this? All right, I do not see any questions. All right. Next up, we'll be going over some properties of triangle congruence. So first up is the reflexive property. We're basically saying angle ABC is congruent to angle ABC. Pretty self-explanatory. Symmetric property, where angle ABC is congruent to angle DEF. And in that case, angle DEF is also congruent to angle ABC. So it's kind of like what we talked about before, where if A is equal to B, then B is equal to A. Next up, the transitive property, which I think is the most important one out of these three, which states that if triangle ABC is congruent to triangle DEF and triangle DEF is congruent to triangle JKL, then triangle ABC is congruent to triangle JKL. This is very similar to what we talked about a few lessons back about the transitive property of angles and the transitive property of sides. So for transitive property of angles, again, if we have like angle A is congruent to angle B, and angle B is congruent to angle C, then angle A is congruent to angle C. So this, I think, is definitely the most important one to remember out of the three. Right. Continuing on. Next up, we have the third angles theorem, which states that if two triangles of one triangle are congruent to two angles of another triangle, then the third angle is also congruent. This is a very, very wordy way to say something really similar. This is basically just saying if, what is it called? If two, so basically it's saying that let me change my color. So it's basically saying if A is congruent to D and B is congruent to E, then C is congruent to F. It's a very like roundabout way. This is like the formal the geometry definition of it. But most of the time these really complicated definitions can be boiled down to a really simple point. So just know that it's saying that when an angle and an angle are congruent and another angle and another angle are congruent, the third two angles will also be congruent. Oh, forgot to. All right, now let's just take another 10 minutes to work through this proof. So we are given the diagram. We're just doing this one. Ignore the other one on this side. Let me just ignore this one for now. Just focus on the one on the left. So we are given what's in the diagram, and we have to prove that triangle ACD is congruent to triangle CAB. If you have any questions while you're working through this, just message me in the chat box, and I'd be more than happy to help you out. And the most important part, remember about any geometric proof, is always stating your givens first. All right, I'm gonna start just gradually writing just start to write the steps on the the board on the screen, sorry. And then if you have any questions along the way while I'm writing it, just let me know. I'll like put down a step or two every few minutes, just so in case if you get stuck on one of the steps, it can help you get unstuck. I will just take another minute or two to wrap up this question. All right, I'm gonna go over the answer now. All right, so first up, right, we want to state our given. So segment AD is congruent to segment CB. Segment AB is congruent to segment CD, which are both givens. Next up, we have segment AC is congruent to segment CA using the reflexive property. Next up, we can say that angle CA, that angle CAB is congruent to sorry, it's tired today. ACD, which is a given, because from here you can see that CAB, this angle right here, is congruent to angle ACD because they both have the two lines. Whenever you see that they share, whenever it has two lines or two angles, two of these dashes, they mean congruence. So that's just something for you guys to know as well. So that, as we said, AD equals CB. How do we know that? Because it's stated in the image, because both of them have the one slash through them, which signifies that they are congruent. Next up, we would use the third angle theorem that we just used. So we would say angle ABC is congruent to angle CDA via the third angle theorem, just abbreviating it slightly. And then from here, we can say that triangle ACD is congruent to triangle CAB because all sides plus all angles are congruent. So from this, once we know that all the sides and all the angles are congruent, we can safely say that these triangles are congruent. In the future, you won't have to prove that every single side and every single angle is congruent, but this is just a good way to, what's it called? This is a good way, this is just a preview for it. But in the future, you won't have to always show. There's other ways to prove congruence instead of solving for every single side and every single angle, because that would be very tedious. Right. Next up, I'm going to be talking about these things. So these are all pretty important. I think these are, I'd say, one of the most important things to learn in geometry, if nothing else. So first up, we have the side angle side congruence theorem. Like what I just said before, you won't have to use you won't have to prove that all angles and all sides are congruent to show that two triangles are congruent in the future. So it states that if using these two triangles in the screen as an example, if segment AB is congruent to segment DE, and angle A is congruent to angle D, and segment AC is congruent to segment DF, then triangle ABC is congruent to segment triangle DEF. And the key thing about this part is the two sides and the included angle, which means that from this you can see that you have this. Let me change colors. So you have this side, right? And you have this side, and the included angle is the angle that is formed by these two sides. So it has to be this angle for you to use SAS. And that's a good way to remember when you say side angle side. You can see first there's one side, then there's the angle, and then there's the next side. You can never say you have this angle here and this angle here were congruent. You wouldn't be able to use SAS for that case. And then for this one as well over here, the two sides are congruent. And then this angle right here, the included angle. So the official geometry definition of it is if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. Next up, let me see. Yep. Next up, we have the isosceles triangle. There's a lot of things. There's a lot of theorems based on the isosceles triangle. You don't have to understand all of these right away. We're just I'm just kind of easing you guys into it right now. So first off, we have the base angle theorem, which states that if two sides of an isosceles triangle are congruent, then the angles opposite to them are congruent. Basically, what this means is that, as you can see here, if this segment and this segment are congruent, which by the picture they are, then the angles opposite to them, so angle B and this one, angle C, would also be congruent. Next up, we have the converse of the base angles theorem, which states that if two angles are congruent, then the sides opposite to them are good. So basically, the opposite of what we just said. From the first off, we started from the sides and went to the angles. But for this one, we say that if C and B are congruent, then the sides opposite to them are congruent. Next up, we have the corollary to the base angle theorem, which says that if a triangle is equilateral, then it is equiangular, which means that if a triangle has all three sides equal, then the angles are all equal. Next up, we have the corollary to the converse of the base angle theorem. If a triangle is equiangular, then it is equilateral. So basically the opposite of what it just said. If all three angles are equal, then all the sides are equal. And now I'm going to just go over a bit of the vocabulary for an isosceles triangle. These are what you call, so whatever the bottom one here is called the base. The base is always the triangle. Sorry, not the triangle, the side that is not congruent to the other sides. Right here, you can see that these two are congruent to each other. The base is always the non-congruent side. These are the two, what we call the base angles right here, the angle B and angle C. It won't always be, this is just an example. It won't always be angle B and angle C being the basis. It could be angle A and angle C, or, angle G and angle Z, anything like that. Next up, we have the vertex right here, which is right here. And then this is what you call the vertex angle, which is just the angle formed by the two legs coming up together. And then the legs are what you call the two congruent sides. So leg and leg. Does anyone have any questions on this? All right, I will keep on going. Next up, we have the SSS congruence theorem, or the side-side-side congruence theorem. Usually, in geometry, I don't know, teachers, it kind of differs from teacher to teacher, but usually, they won't make you write out, SSS congruence, or they don't have you write out at side-side-side congruence theorem. Usually, they have you just write SSST at most. And then that would be enough to show that what you're talking about. Basically, what it says is that if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. Basically, if segment AB is congruent to segment DE, and segment BC is congruent to segment EF, and segment AC is congruent to segment DF, then triangle ABC is congruent to triangle DEF. So this is another useful way to prove triangle congruence. And as you can see in this case, what is it called? You won't have to prove that any of the angles are congruent to each other. You just have to prove that the sides are all congruent to each other. So you use these based off of pretty much what the information, what the given gives you, what kind of information are you given, and from there you can kind of postulate and derive and come to the conclusion of, which congruence theorem will I need. There are still a few more, I believe. Next up, we have the hypotenuse leg congruence theorem. A lot of congruence theorems today, which you can just abbreviate as HLT. That's fine for me. and then for the other one, SSST, and then the sorry, not that one. As and then the side angle side theorem as well. So far we have these three. So the hypotenuse leg congruence theorem states that if the hypotenuse, which is the longest side of a right triangle, which the side opposite to the right angle, if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of the second right triangle, then the two triangles are congruent. So if segment AB is congruent to segment DE, segment AC is congruent to segment DF, the and measure of angle C is equal to measure of angle F is equal to 90 degrees, then triangle ABC is congruent to a triangle DEF. And then, of course, basically what it's saying is that as long as this one, the hypotenuses are equal, are congruent, the go opposite to the hypotenuse is a right angle, and the legs are congruent, then we can use the HLT. In this case, it just shows that these two legs are congruent, right? It doesn't have to be these two. It can be the other leg as well. As long as it's the same two legs, you can't have, for example, in these two right triangles, right? You can't have this one and, you can't, what's it called? You can't say this one and this one, right? You have to make sure that the two sides correspond to one another and they're congruent to each other. Does anyone have any questions on any of the congruent theorems? All right. All right, next up, we have the angle side angle congruence theorem, which states that if two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. If angle A is congruent to angle D and segment AC is congruent to segment DF and angle C is congruent to angle F, then triangle ABC is congruent to triangle DEF. As you can see, remember the most important part is that it has to be the included side. So the side between the two angles, it can't be this side, it can't be this side, can't be this side, can't be in this side. It has to be the side that is between the two angles for you to invoke the angle side angle congruence theorem. That's the most important part for the side angle side theorem, the angle side theorem. You have to remember that so you don't make the mistake of using the wrong one or using it when you shouldn't be able to. So, like for example, right, if you have this, sorry, wait, that's bad. So you have this, you can use this angle and these two are congruent, right? You can use the angle side angle theorem, but in this case, you cannot use either of these two sides. All right, I believe this is the last one, the angle side congruence theorem, which is AAS. If two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of a second triangle, then the two triangles are congruent. So if angle A is congruent to angle D and angle C is congruent to angle F and segment BC is congruent to segment EF, then triangle ABC is congruent to triangle DEF. The most important part about this is not getting angle side and angle mixed up. They do not correlate. They do not equal one another. Remember, angle side is only for when it is not the included angle, and angle side angle is for when it is the included angle. So just remember to make that key differentiation between the two. And obviously for side, you don't need that. You just need to know that all three sides are congruent. All right. And that is the end of today's lesson.